Okay, so today we're going to be doing some trigonometric equations. We're going to factor first, we're going to separate into pieces that equal 0, then we're going to draw our cast rule, our sine, cos, or tan function, and then we're going to find all thetas, or angles. So trigonometric equations basically are solving for all thetas, or angles, if you will. So the key is to solve for all possible thetas. How to solve for trigonometric equations that we just went through. I'll give you a moment to write that down. Write it down. And then after that moment, we'll begin. And 1 over the square root of 2 is actually the exact value for 45 degrees, or pi over 4, with the special triangles. So theta 1 is going to be 45 degrees, and then we'll find the corresponding angle where the sine function is positive, because 1 over the square root of 2 is positive. If it was negative, then we would find it in the, using our cast rule, in the cos quadrant and the tan quadrant. But because it's positive, we're going to find the corresponding angle in the sine quadrant. And it's just 180 minus theta, which is 45 degrees. So 180 minus 45 is 135 degrees. And if you want it in exact values, so there's both your answers. Moving on. So it's just 180 minus 60 degrees, and then 180 plus 60 degrees. Okay. So that's both the answers there if you want it in exact values. Or if you want it in degrees. Moving on. So this is a difference of squares. So 1 is actually the exact value for 45, or pi over 4. For the tan exact value using our pi over 4 special triangle. So theta 1 is going to be 45 degrees. And then theta 2 is just 180 plus 45, which is 225. And then, so it's just 180 minus 45 and 360 minus 45 as well. And because the 1 is negative, we're going to be using the cos quadrant and the sine quadrant using our cast rule. So quadrant 2 and quadrant 4. And then we have all of our possible angles. Again, if you want it in exact values, I have that too. And those are both of our answers in degrees and in exact values. So yeah, that was question number 3. Moving on. The reason why 3 over 2 won't work is because if we draw the sine function, it never increases above 1 or negative 1. So 3 over 2, 1.5 will not work because it doesn't reach that y value. But a negative a half will work. We're using the sine inverse function. Q1 stands for quadrant 1. Some people refer to it as the fake angle because it's not the angle we're looking for. We're looking for the angles in quadrants cos and tan. Okay, so there's our answers in degrees and our answers in exact values or radians. So I did another video on converting degrees and radians or interchanging them. If you're having trouble figuring out how I went from degrees to radians, please watch that video and it'll clear things up a lot more. Moving on. That's just in case you're wondering how to convert degrees into radians. So the reason why the 3 didn't work, I know we just went over this, but sine only goes up to 1 and negative 1 for the y values. 3 will not work because it does not reach 3 within the y values. Negative 1 will work. So if you add 90 degrees to 180, it'll be 270, and if you subtract 90 degrees from 360, it'll be 270, so it's the same, so we only need to do one angle. And there's our answer. Moving on. So, tan is a little bit different. Tan does reach numbers higher than 1 or -1. So for these ones, when we input it into the inverse function, like so, we will get an answer. So we just need to do 180 minus 71.56 degrees and 360 minus 171.56 degrees, which is 108.44 degrees and 288.44 degrees. Moving on to the next question. And for this one, there's no converting to exact values, but there is converting to numerical radians, but that I didn't do. So we'll just take the degrees version for the answers as well. So next up is graphing and transformations of sinusoidal functions, otherwise known as trigonometric functions, otherwise known as sine, cos, and tan. So that'll be up next, and I hope you found this video helpful, and I'll see you later.